Good morning, grade 11. The Afrikaans class said they were having a bit of trouble with question 3 and 4, so I'm just going to give you a quick explanation. It's the same as question 1 and 2, except in question 1 they told you the lines were perpendicular or parallel. Here you just see it on the sketch. So at 3a you're going to use A and B because it's the only line whose gradient you can calculate. So you calculate it with the gradient formula. And then because they've shown that those two lines are perpendicular to each other, you're going to take AB's gradient, swap it around and give it a negative. Then you've got the gradient of CD. Then there's a coordinate. You substitute into the formula, into X and Y. Then you can calculate the unknown value of C in the equation for the straight line. Okay, B the same except the lines are parallel. So you're going to calculate AB's gradient. Because the lines are parallel, you use AB's parallel as CD's parallel. As you use AB's gradient as CD's gradient because the lines are parallel. When you substitute that gradient into the formula, you also substitute in the coordinate of C there, and then you can find the unknown value of C in the equation. At C, again, it's perpendicular, so you calculate the gradient of PR. Once you have that gradient, you swap it around and give it a negative, then you've got CD's gradient. But here you don't have a coordinate. But they have given here that this line and this line, they're equal in length, which means that CD is the midpoint. So you have a midpoint formula, then you can calculate D's coordinate. When you have that coordinate, you've got the coordinate to substitute into the equation for CD and then find the unknown C value in the equation. D, also parallel lines, but there are no coordinates, so you can't calculate AB's gradient with the gradient formula, but you've got the inclination angle. So if you type into your calculator tan 135,435, then you'll get the gradient of AB. Once you have the gradient of AB, you use that gradient for CD, just as it is because the lines are parallel. They didn't give you a coordinate, but they gave you that point of intersection. And then where it's -2, it means that it cuts the x-axis right there. And then there's actually a coordinate of -2 and 0 because it cuts the x-axis right there. At number 4, they've given you the equation of RQ. There's RQ, so you just get that equation into standard form. The first one, they want you to calculate the inclination of RQ. So the inclination would be the angle right there. So you've got a part of it, it's 25 degrees, but we want the whole angle. So you just say tan theta equal to the gradient when it's in standard form. Remember, take it over first. Once you have that inclination angle there, let's say maybe it's 60 degrees. Then you know that whole angle is 60 degrees. But they only we want at B to find the gradient of PQ. So if we can find the inclination of PQ, we can find the gradient. So if that angle is, for instance, 60 degrees, we know that this smaller part here will be 35. And that would be the same size as the angle there. And when you have that angle there, it means you've got the inclination angle. So you can just say tan, and whatever the remainder is or the difference is there, then you can find the gradient of PQ.